Alright guys, in the previous video we had seen the outline of the game. We have a play method and we had a place method. Play method alternates the turn between the players X and O. Even number turns is for X, odd number turns is for O. And place method checks whether the position is a valid one and a vacant one. If it is so, it allows the player to place it, or if not, it asks for input again and again till he gives a valid position. So this is how the game had gone till now. So let us see this particular thing that has been undefined, 1. So let us define that method now. Define 1. For 1 we have the same thing, symbol as an argument. We have been passing symbol. So let us see. So what should you check? Check rows. You should check for rows. If any of the row has been occupied, or you should check for columns. If any of the columns has been occupied in a consecutive manner, or check the diagonals. If any of the diagonals has been occupied. So you have to check all these things and return the answer. If any of these things has been occupied, then that person has 1. So see, check rows, check columns, check diagonals. All these are intuitive to us. We need to define it. Let us define it one by one. Check rows, define, check rows. We have passed the symbol. Okay. I need to check each of the 3 rows. So I need to use a variable to check it. So let me call it as row R. Let me call it as R. R in the range of, there are 3 rows. So let me say 3. R in the range of 3. For each row I will have a counter. Count is initially 0. That is, we haven't counted the occurrence of that symbol in the row. So count is initially 0. Now let me iterate through every cell in the row. So for that let me use C, column. That is, each row has 3 columns, right? Has a cell of 3 columns, right? One cell belonging to each column we have, right? So we have to iterate over each of these cells. For C, for cell or column, you can take it anything. For C in the range of 3, because each row has 3 cells. So C is in the range of 3. So let me call it. So I will say if board at the R and C index contains the symbol, I will increment my counter. Count equal to count plus 1. So why do I use a counter here? Because it may be the case that in some column or some row X and the third thing may be O. In that case it is not a winning placement. X is a winning placement. So I need to count how many times I had seen the symbol X. So that is why I am using something called a counter. At the end of this loop, where we had iterated over each cell, I will check the value of the counter. If counter is equal to 3, because each row has 3 cells. If all 3 cells have the same symbol, then it is a winning move. I should print that it is a winning move. So let me print this particular symbol has 1. Let me say this person has 1 and I will return true. Here I am returning. So this particular functionality comes to an end. In case if the first row doesn't satisfy it, the loop for R will be checked once again, and for the second row the same check would be done. For the third row the same check would be done. So once for all the rows this check has been done and none of the places this has been encountered. That means there is no winning movement along the rows. So in that case this check rows thing, that is, the winning is not due to occupying 3 consecutive cells of any row. Along any row the person has not occupied 3 consecutive cells. So in that case you should say it is not a winning thing. So I should return false. That is, the person has not occupied 3 consecutive cells along any row. That is the meaning here. I hope you can understand this check rows functionality. Otherwise, no problem. You can pause the video here, dry run the code, then you will definitely understand it. So check rows is done. Check columns is pretty much similar. So let me just copy paste it. Copy. Let me paste. Okay. This is check columns. Just the names change and some indices change. Because here the column value is fixed and rows change. So let me change this as C and R. So the rows change. That is, the column value is fixed and rows change. So that's the only change here. Otherwise, it is pretty much the same. I guess you can understand this. Let me show you. See, in check rows, we fix up this row. We check each cell, we count. In check columns, we fix up the column. In each of the row corresponding cell, we count. If you don't understand, please don't worry. You try running is the key here. You think like a computer. Just have an index table, something like this, and try run it. You will definitely understand it. It is very easy. All that it requires is some amount of thinking. That's it. It's very easy. Please make sure that you understand till here. Okay, check rows is done, check columns is done. Now check diagonals. So yeah, I'll show here. Wait. Okay. See the diagonals. 0, 0, 1, 1, 2, 2. The general format, it is of the form I, I. So both the values are same along this diagonal. And this diagonal, it differs, so it's just 3 cells, so let us manually do it. 2, 0, 1, 1, 0, 2. So please make a note of these values, that's it. So for this I, general format, we can use a loop, something similar to what we have used in rows and columns. Just for that other case, we need to use the thing manually. Let us do it now. Define check diagonals. Check diagonals for the symbol. Check it. So for that diagonal, let us do it. If board of 0, or maybe we can even manually do it, no problem. It is up to you. You can use a loop as well as you can do manually, anything. 0, 2 is equal to board of 1, 1. That is allowed in maths but not in programming. So we have to use AND operator and we have to say board of 1, 1 is equal to board of 2, 0. That is one of the diagonals, and that particular thing must be equal to this corresponding symbol. Only then this person has 1. So let me check it. You can use any of the 3 values. I am using 1, 1. That is equal to symbol. In that case, you say this particular symbol has 1. And you return true. Say true. Okay. Next is along the other diagonal. Here you are returning. So in case if this diagonal has been satisfied, this particular functionality would come to an end. If this diagonal has not been satisfied, only then the control would be transferred here. You have to check this diagonal. Board of 0, 0 is equal to board of 1, 1 and board of 1, 1 is equal to board of 2, 2 and board of 1, 1 is equal to symbol. This can be written using a loop as well. I would leave it as an exercise for you guys. Please do try using a loop to simplify this thing. Instead of using these many comparisons, you can simplify it. Alright, if that is the case, then this is pretty much the same. So let me copy paste it. Copy, paste. In case if both the cases didn't satisfy, then it means along the diagonals there is no winning move. In that case you have to return false. So we had checked rows, checked columns, checked diagonals. And see, this one functionality is check rows or check columns or check diagonals. If in one of the places OR operator works in this manner, if at least one of these values is true, the final answer is true. If along the row or along the columns or along the diagonals there is a winning movement, then you would return true. That is, that person has won. If all three places there is no winning movement, only then it will return false. That is, the person has not won. So this is how this functionality works. Okay, let me save it. Okay, so I hope you would have understood the code till now. Please do pause, understand the flow of the code really well, and then proceed towards running the code. You can try dry running it. As I said, dry running is the best way to understand the computer's perspective. Please do understand really well before proceeding further. Let us run this code and see what happens in the next video.